Alright, today we are discussing section 8.3, how to show a quadrilateral is a parallelogram. Our goal is to use the properties to identify parallelograms. This section is very similar to section 8.2, except now we are trying to show something as a parallelogram versus given that it is one. There are 5 ways to show that a quadrilateral is a parallelogram. Number 1. As you can see by the markings here, if we can show that both pairs of opposite sides are parallel, you can show that a quadrilateral is a parallelogram. Option number 2. We look at the diagram here, and we see that both pairs of opposite sides are congruent. It is our second way to prove that a quadrilateral is, in fact, a parallelogram. Option number 3. As you can see by marked on the diagram, both pairs of opposite angles are congruent. All right, so those are the first 3 options. Option 4 is the one that is a little bit different and was not shown in section 8.2. Notice that on both of these, the sides here are congruent and parallel. So this is one pair of sides congruent and that's the big part, it has to be both congruent and parallel. The common mistake is where you have something where you have one side congruent and the other side parallel. That does not work. It has to be the same pair of sides congruent and parallel. Alright, and lastly, option number 5. As you can see here, we are dealing with diagonals. If the diagonals bisect each other, then your quadrilateral is in fact a parallelogram. So these are the 5 ways, if you're given any type of a quadrilateral, that you can say, yes, it is in fact a parallelogram. So we have here a picture of a handrail from a city building. I've highlighted the pieces of the rail. The question is, does this rail form a parallelogram? Yes, it does form a parallelogram because our top and bottom are both 3 feet, so they are congruent. Our left side and our right side are both 2 feet. They are congruent. So yes, it is a parallelogram, and it is because of option number 2. Both pairs of opposite sides are congruent. And again, when explaining, you need to write out, I don't want to hear, or I don't want to see option 1 or 3 or 4 or 5. You need to write out when it says explain. Very similar problems you're going to see from section 2 are in section 3. For example, what value of x makes ABCD a parallelogram? Here we happen to be dealing with diagonals. As you can see, these 2 diagonals are congruent. They're both given as 8. So in order for this to be a parallelogram, the other pair of diagonals also need to be congruent. So that would mean 4x is equal to 8x minus 32. And we are going to solve. So we're going to subtract the 8x from both sides. Yes, I know you're going to have a negative number. But when you divide both sides by -4, you're going to find that x equals positive 8. to justify the diagonals bisect each other. That is how we are justifying why did we set it up the way we did. Our next example is a coordinate one. So we have a graph, and it says here that ABCD is a parallelogram with coordinates of A is the point -4, 4. So we're going to plot that point. B is 4, 6. C is 3, -1. And we don't know D. How can we find D? There are a couple different ways we can look at this. We can look and say, well, we know that opposite sides are parallel, which means they have the same slope. So it doesn't matter which way we go. I'm going to look here from B to C. I'm going to count down 1, 2, 3, 4, 5, 6, 7. So I'm going down 7 and over 1. So I'm going to do the same thing from A. I'm going to go down 7. 1, 2, 3, 4, 5, 6, 7. And I'm going to go to the left 1. There's my new coordinate D. And then I would connect like that. How can I check to make sure I did this correctly? Well, since these two are parallel, we know that these two must also be parallel. So I'm going to check from B to A. What do I go? I go 2, 4, 6, 8 left. And I go down 2. I'm going to see from C to D. Is it the same way? Am I going left? 8. So I go 2, 4, 6, 8. Yes, I go 8 left. Am I going down 2? I go over, and yes, I in fact go down 2. So, in fact, I have checked it. I've solved it one way, checked it the other way. I know all sides are both pairs of opposite sides are parallel, thus creating a parallelogram. So my last question is, what is the coordinate of D? That's what the problem asks for. So the coordinate of D is 1, 2, 3, 4, 5, -5, -3.